Today we're going to be talking about calculating map scales and mystery. Mwah! What mystery, you say? Well, we're going to talk about how King Henry died by drinking chocolate milk. Yes. Here's chocolate milk. Here's King Henry. Oh, I love chocolate milk! All right. So, what does King Henry have to do with map scale? Well, a map scale shows the relationship between a distance on a map and the actual horizontal distance on the ground. It is usually represented in the ratio 1 to r, where these are unit rates, or as a fraction 1 over r. Now, in order to really get a really good sense of map scale, you kind of have to think back about the acronym King Henry died by drinking chocolate milk. Now, what that means is that's one easy way to remember how everything fits in the metric system. So we start with our base unit, and that could be 1. So like 1 meter. And then in 1 meter, you have 10 decimeters. So you notice I multiplied by 10. And then to get from 1 meter to 100 centimeters, you multiply by another 10, and then you multiply by another 10 to get to millimeters. So you end up multiplying to get from meters to millimeters. 1, 2, 3. 1, 2, 3 zeros there. Then if you want to get bigger, you'll notice that these values get smaller. 1 meter is representative of 1/10 of a decameter. So you're dividing by 10, and then a hectometer, again, dividing by another 10, and then dividing by another 10. So it's useful, really, to know how to convert among different values within the metric system. And again, the more you practice, the easier it gets. But it might be important to think about like how many centimeters are in a kilometer, for example. And that'll help you as we get to map scale. Because map scales, oh man, got to do that over. Here we go. Because map scales often have a unit rate in centimeters. So let's take a look at a sample problem. A distance of 4 centimeters on a map represents an actual distance of 5 kilometers. Find the scale of the map in the form, let's go 1 to r. So let's start with this first, don't even look at the next one. Now if you want to try and figure that out, you can go ahead and pause this and work it on your own. But if you don't, what you can do is take a look at what I'm about to do now. So here we are back again, and now I'm in green. A distance of 4 centimeters. So 4 centimeters is to 5 kilometers. All right, so I'm going to break down my plan here. Right now I'm in centimeters to kilometers. Now I'm going to make sure I'm at, next step is going to be centimeters to centimeters. And then finally, to get to my unit rate of 1 to r, I'm going to figure out then 1 centimeter equals how many centimeters on the map. So first thing I need to do is convert kilometers to centimeters. Maybe I don't know how many kilometers are in a centimeter. But I do know that kilometer, kilo, if I look back, oh no, where'd my picture go? One more. Oh no. Hold on, here we go. All right, so King Henry died by drinking chocolate milk. Here's my base. And then my kilometer. I'm all the way down here, and I want to move up. So 4 centimeters is 5 kilometers, represents 5 kilometers, which means 4 centimeters represents 5,000 meters, because 5 kilometers represents 5,000 meters. I'm getting closer. I'm not quite centimeters to centimeters. Some of you will already figure out how many centimeters are in a kilometer, and you can make that calculation a little quicker. Then let's go 4 centimeters represents, let's see, 5,000 meters. 100 centimeters equals 1 meter. So I'm going to multiply this by 100, adding 2 zeros. So 5, 0, 0, 0, 0, 0, 500,000 centimeters. All right, so now I have centimeters to centimeters, and you'd think you're done, but you're not, because we need to get it in the rate of 1 to r. So that means I need to divide this from 4 centimeters. I need to divide this by 4 to get to 1 centimeter, which means I also need to divide this by 4 to get to my final unit rate. So now I have 1 centimeter is equal to 125,000 centimeters. So therefore, those 3 dots mean therefore, 4 centimeters is to 5 kilometers, and my unit rate is 1 to 125,000. That is how an understanding of the metric system can help. Now let's go to the next part of the problem. If the distance between the 2 cinemas on the map is 6 centimeters, find the actual distance between the 2 cinemas. Now you could use all this information that we just used, or you can set up a proportion between the 2 values, and that's going to take a while. Let's make it bigger. There we go. Hopefully you wrote everything down. If not, you can pause, go back, modern conveniences. All right, so here we go. We know that 4 centimeters is to 5 kilometers, as 6 centimeters is to x kilometers. I'm going to ignore my units for right now and transfer this over, so I have 4 over 5 is equal to 6 over what? So then I know when I'm dealing with a proportion, I can cross multiply my values, and instead of this what, we have our variable x, so that when I work on this problem I get 4x equals 30, and I divide both sides by 4, x equals 7.5. So now I think back to my units that I had before. I'm comparing centimeters to kilometers. Find the actual distance between the 2 cinemas. So the actual distance, if we're thinking about real life situation, we're not thinking about things being centimeters away or even meters away. Meters are pretty close. Think about a yardstick, it's about the same size. So we know our answer has to be in kilometers. And that's how we deal with map scale when you're talking about a linear relationship. It gets a little trickier when you're dealing with area. Why? Well, if we're comparing a square, let's say 1 to 1, that gets an area of 1. If we now go to the next square, 2 to 2, from 1 to 2, it's really one up, But from the area, it's not a ratio of 1, but it now goes up to 2 times 2, which is 4, and then 3 as you go up 1 here. But then 3 times 3 ends up being 9, so you end up getting a lot bigger each time you go up. So it's a little trickier that way when you're dealing with area. Keep that in mind, that the ratios grow much, much faster. Okay, so here's what we need to know. Scale of a map is 1 to 40,000. And remember, if you're not given a value, that it's usually 1 centimeter to 40,000 centimeters. A rectangular field is 3 centimeters by 2 centimeters on the map. Find the actual area of the field. So first you need to think about what units will we use. There are several ways to do this. Oftentimes for me, I find it's helpful to draw a picture. So I know that it's 3 by 2, and that my area then is going to be 6 square centimeters. How is this important? Let's go ahead and finish this up. First thing I want to do is set up my ratio. Now notice my ratio here is centimeters to centimeters. But because we're dealing with area, we need to eventually get to centimeters squared. Here's how I'm going to do that. Let's take a little sidebar over this way. So I know originally I have 1 centimeter to 1 centimeter, and that's going to get me 1 square centimeter. Well, 1 square centimeter is going to represent what? Let's take a look at my scale. 1 to 40,000. So 40,000 centimeters equals 0.4 kilometers. How did I get that? Think back to the the acronym and start jumping up. Okay, so back over here, that means for every 1 centimeter, I can represent that as 0.4 kilometers. And 0.4 kilometers. So then my area ratio now becomes 1 square centimeter to 0.16 square kilometers. So now if I know that 1 square centimeter is to 0.16 square kilometers, then now I can talk about my problem here. I know that I'm dealing with 6 square centimeters. 6 square centimeters represents how many square kilometers? That's going to be the actual area of the field. From here, I just go ahead and do the math. I cross multiply. One times x is just going to get me x. I'm ignoring the units for now. 6 times 0.16 is 16 times 6 is 96, but I have 2 decimal points. And now I slap my units back on. So my answer, the actual area of the field, is 0.96 square kilometers. Now if the actual area of the region is covered with sagebrush, if the actual area of the region that is covered with sagebrush is 2 kilometers, find its area on the map. So now because I did all this work earlier where you might have been asking, why did you do it that way, Mr. Chavez? There's probably a different way that'll get my answer. Yes, but now I have this usable ratio that helps me out. So now I know that 1 square centimeter, we're going to blue now, is equal to 0.16 or 1600ths square kilometers on the map, which means in real life, my sagebrush is 2 square kilometers, because I'm making sure my units match, is representative of how many square centimeters. So really getting your ratio set up, getting your unit rate is the most trickiest part. After that, you're just plugging in numbers. So then I cross multiply, and I'm ignoring the units here. 1 times 2 is 2, so 2 equals 0.16 x. Now I'm going to divide to get x by itself. Divide by 0.16. I'm dividing by a really small number, so I'm asking how many times does 0.16 fit into 2? It fits in a lot of times. In fact, it fits in 12.5 times. So x equals 12.5. Well, now I need to think about my units. What was I comparing? It looks like centimeters to kilometers. It looks like square centimeters because we're dealing with area. Remember, when you're dealing with area, your units have to be square values. So my answer is 12.5 square centimeters. And again, as we work on this in class, we're going to practice more values so that it becomes easier to do. But there are 2 examples with map scale involving a linear relationship and an area relationship.